This presentation is a continuation of a previous one where we're going to show some examples this time and cover cube roots as well as square roots. From the last presentation, we noticed that our format here is in what we call vertex form, where A is a coefficient out in front of the radical that's going to change the shape of the radical. Remember, if A is, there's y equals square root of x. If A is greater than 1, it's going to be a taller graph. If A is less than 1, it'll be a shorter graph that is closer to the x-axis here. That's how A affects things. H and K help me locate the vertex. If H is positive, it's going to shift this horizontally to the right. If H is negative, it'll shift it to the left. If K is positive, it'll shift the origin or the vertex up, and if K is negative, it'll shift it down. So let's look at a quick example here. If we were to plot y equals 2 times the square root of x minus 3 plus 1, we should first find our vertex, like it says here, and this means h is going to be 3. Notice it's not negative 3 because it's looking for x minus 3. The minus is built into the formula, so minus 3 is h is 3. K is 1. It's looking for a plus 1 out here, and we've got a plus 1, so K is 1. This means it's going to shift to the right 3 and up 1. So my origin here, if I were looking at my graph, would go from the main origin here. It's going to shift it over 3, 1, 2, 3, and up 1. So my new origin is going to be right here. That's where my graph is going to stay the same if it was a coefficient of 1. Oh, but it's a coefficient of 2, so it's going to be a taller graph than usual. Well, how do I know how tall? Well, let's create a table of points, and we'll try to create perfect squares inside the radical. That's how we're going to make it easy for ourselves. Now, what that means is this, okay? I'm going to do a graph of x and y values here, and I'm going to try to find x values that make a nice convenient number under the radical that'll come out easily. So 0 would be a first number I'd like to get under there, and besides, my vertex is 3 and 1, so let's try that just to confirm it. When x is 3, if I plug in a 3 here for x, I get 3 minus 3 is 0. Square root of 0 is 0. 0 times 2 is 0. 0 plus 1 is 1. It works, okay, and it should. Okay, so 3, 1 is my first point right there. Now, what's the next perfect square? This is what it means when we say create squares. The next perfect square is 1. So if I wanted a 1 under the radical, I would try an x value of 4, because 4 minus 3 is 1. Square root of 1 is 1. 1 times 2 is 2. 2 plus 1 is 3, and there's my next point without having to use a calculator or any decimals. 4 and 3. And there's my next point, knowing that this is my origin here. The next perfect square would be 4. How do I get a 4 under the radical? Well, if I've already got the minus 3, I'm going to need a 7 for x, so I'm going to go 7. 7 minus 3 is 4. Square root of 4 is 2. 2 times 2 is 4. 4 plus 1 is 5. So at 7, I'm going to get 5. 1, 2, 3, 4, 5. And here's what my graph is going to look like. Starting from the origin, it's going to go up like this and out like that. And there you go. That's how you do that. Okay, so I only had to find 3 points. If I had more graph paper, I would go out to the next perfect square, which is 16. So 16 minus 3, I'm sorry, to get 16 under there, I'd need a 19. So I'd go all the way out to x equals 19, and I'm out of graph paper for that. But 19 minus 3 would give me 16. Square root of 16 is 4. 4 times 2 is 8. 8 plus 1 is 9. So I'd get one more point, but it's off my graph paper. But you see how I'm finding numbers here that will give me perfect squares there? 4 minus 3 is 1, so square root of 1 was 1. That was easy. 7 minus 3 was 4. There's a perfect square under the radical. 19 minus 3 was 16. So I'm trying to get 0, 1, 4, 9. I didn't do 9, did I? Okay, so if I wanted a 9 under there, I could go 12 minus 3, which would give me, let's try that. Let's go 12. 12 minus 3 is 9. Square root of 9 is 3. 2 times 3 is 6. 6 plus 1 is 7. So at 12 would be 7. And I'm still off the graph, but I skipped that one. Okay, so I hope you can see how I'm getting perfect squares under the radical. Here's another one. We've got y equals minus 3 square root of x plus 1. First of all, my a is minus 3. What is that going to do? It's going to flip the whole graph negative. Okay, h is a minus 1. Remember, they're looking for a minus h under there. So when I have a positive number, it's going to be minus 1. And k is 0. So my first thing is find the vertex. A minus 1 for h shifts it to the left one. And that's all I do. K doesn't shift it up or down at all because k is 0. Now I'm going to try to find points again. I'd like to first get a 0 under the radicals. Let's try that origin. Minus 1. or find my vertex here. When x is -1, I get a 0 under the radical. The whole thing is 0, and that's my origin. The next perfect square would be a 1. So if I tried an x of 0, when x is 0, I get a 1 under the radical. Square root of 1 is 1. 1 times -3 is -3. Okay, so when x is 0, I get a -3. And clearly this graph is going to go down like we suspected. The next one under the radical would be, I've already tried 0 to get a 1. The next one would be a 4. So if I tried an x of 3, 3 plus 1 is 4. Square root of 4 is 2. 2 times -3 is -6. So when x is 3, I get -6. And that's about all the graph I'm going to have room for. This graph is going to look like this. Clearly a square root function, but it starts in my origin, -1 and 0, or starts at my vertex there. The -3 means it's going to be taller than my regular square root of x graph. And what this means is I am going to have it be negative because of the -3 sign out front. Hope that helps you with square root functions and stating domain and range. Okay, let's talk about domain and range here. The vertex is going to be -1, 0. Okay, and my domain is going to be all x that are greater than or equal to -1, because I can't have any x's less than that. It'd be undefined because I would get a negative under the radical. Okay, see that? At -1, I get 0, and I can't have anything less than 0 under the radical. So that's why my domain is limited to all x such that x is greater than -1. The range is going to be all non-positive real numbers, or I'm going to be all y such that y is less than or equal to 0. I can have a y of 0, but I can't have anything positive, and that's all because of this -3 out front. Only positives can come out from under the radical. Therefore, positives times this -3, I will only get 0 or negative numbers. So that is how I do my domain and range for that problem. All y such that y is less than or equal to 0. Okay, and all x such that x is greater than or equal to -1. So there's my domain and range. We didn't talk about cube roots, and we've got to understand that cube root functions are very much like square roots, except they can have this negative part of the graph out here. This part of the graph can work because you can have a negative number under the radical. You can have a negative come out of the radical. So we can have both a negative x and a negative y. Okay, but let's try to find the center of this using the same principles. We'll try to create cubes, perfect cubes in the radical, and we will try to find our vertex first, so the center of our root graph. Okay, so let's try that with an example problem here. Okay, we've got cube root of x minus 1 equals -2, so let's first find our values. H is 1, k is -2, and a is actually 1. So it's going to be the same basic shape, it's just going to shift according to h and k. So positive h shifts at 1, a negative k shifts it 2 down, so my whole graph is going to be centered around that center right there. Now here's the part that students sometimes struggle with, is I'm going to try to find my perfect cubes under there. The first perfect cube would be 0, so let's try to get a 0 under that radical. That would be an x of 1, because 1 minus 1 is 0. Cube root of 0 is 0. 0 minus 2 is -2. Oh, and there we go. There's our origin. 1 minus 2. Perfect, okay? The next perfect cube in either direction would be a -1 or a 1. So let's start with x equals 0. That's easy, right? 0 minus 1 is a -1. The cube root of -1 is -1. So now I have a -1 here, okay? And a -1 minus 2 is a -3. So at 0, we're going to get a -3 value. When x is 0, we get y of -3. Let's try to get a positive 1 under there. That'd give me a 2, right? 2 minus 1 is a positive 1 under the radical. Cube root of positive 1 is 1. 1 minus 2 is -1. So when x is 2, this is -1. And this makes sense because my cube root's going to have to do that quick change right here around the vertex, around the center of the graph. Now it's going to start spreading out quickly as we go that way. So let's look for our next perfect cube, okay? A -8 would be, oops, -8 is what I'm looking for under the radical, so I need a -7 here to get that. -7 minus 1 is -8 under the radical. Cube root of -8 is -2. -2 minus 2 is a -4. Okay, I hope you see how I got that. So at -7, I'm going to get -4 right here. Notice how quickly the graph changes to be going like this. Looks like the same thing's going to happen up here too. If I want a positive 8 under that radical, since there's a -1, I've got to get a x value of 9, because 9 minus 1 will be 8 under the radical. So let's try an x value of 9. 9 minus 1 is 8 under the radical. Cube root of 8 is 2. 2 minus 2 is 0. So when x is 9, the y value is 0, and that would be right about here, just off my grid here. Now I have enough points to know what my graph looks like. It's going to be very sharp here. It's going to do a quick change over here. Oops, missed it. And it's going to go back out like this. Okay, not the smoothest picture, but I think you get the idea. That's how I graph these functions. Okay, it's a bit messy, but I think you get the idea. Notice it shifted over 1, down 2 for my origin right there, or my vertex right there, 1 minus 2, because of h and k. All right, h is -1. I'm sorry, h is 1, k is -2, so went to the right 1 and down 2. All right, if we were to talk about domain and range, there's no x values that are outside the domain, so that would be all real numbers. Okay, that'd be my domain. My range would be all real numbers because there's no y values I can't have. As x gets infinitely big, y will get infinitely big, although slowly. It'll get there slowly. When x goes to -infinity, I can have a negative under the radical. Therefore, there's no x values and no negatives under the radical that eliminate x values. So all x's are still in play as I go to -infinity. And as x goes to -infinity, y will also go to -infinity. So both the domain and range are all real numbers. Hope that helps you do those problems. Hope that helps with all your graphing. And that is how you graph cube roots and square roots.